Today we are looking at solving radical and exponential equations. First, we are going to start with number 2, and your first step, as listed, is to isolate the radical. So this looks different for every problem. For this one, I'm going to subtract over my 3. Whatever I do to one side, I have to do to the other. Then I'm going to divide by -1. And then I get 4th root of m equals +3. So now, step 2 is to raise each side of the equation to the power of the index. So my index for this equation is 4, so I'm going to raise each side to the power of 4. The 4th root and the exponent of 4 cancel each other out, leaving you with m equals 81. Now you're going to graph the original problem in Desmos to check for extraneous solutions. These radical problems create a lot of extraneous solutions. Another way you can check is by plugging it back into the original problem. So 3 minus the 4th root of 81, so 3 minus 3 equals 0. That is correct, and it is not an extraneous solution. Again, we will talk tomorrow in class about how to plug these equations in Desmos to get your intersection point. Number 3. Step 1, isolate the radical. I will do so, in this case, by subtracting over the 10. Step 2, raise each side to the power of the index. Well, in this case, our index is 2. So the square root and squaring it cancel each other out. You're left with a plus 7 equals 1. Then you just solve the linear equation. A equals -6. Again, you can plug this into Desmos and this into the second line of Desmos and click their intersection points to check, or you can plug it in by hand. -6 plus 7 is 1. Square root of 1 is just 1. 10 plus 1 is 11, so this is correct. You have to check every problem to make sure it works. All right, now let's skip down to number 6. Number 6 has an exponent, a fraction exponent instead of a radical. So this one, you solve it the same way. You want to isolate the portion with the parentheses in the exponent. That is step 1 for all of these equations. Then you're going to raise each side to the base of the exponent. Remember, this is the same thing as a cube root. So I'm going to cube everything. These will cancel each other out, and you'll just be left with 7p minus 1. Then -4 cubed, remember you're using your parentheses, so it's -4 times -4 times -4 gives you -64. Then you just solve the linear equation that remains. Adding over your 1. Dividing by 7, p equals -9. Last step, plug it in Desmos. You'd plug this into one line and the y equals 7 into a second line and click the intersection, and it does work at -9. So that is a solution. Here's an example, number 7, where it would not work. So first, we're going to isolate the radical by adding over our 9. That's always step 1. Don't forget to do that before raising everything to the power of your index. Now, once it's isolated, now we can raise everything to the power of 4 in this case. So we're left with 8k plus 12 equals +16. Subtract over your 12, just solve your linear equation. Divide by 8. 4 over 8 is 1/2. And then we will plug it in and check. If you don't want to do this mental math because that leaves room for error, you would plug this into one line of Desmos and y equals -11. And you will see that they do not intersect at all, so this one is an extraneous solution. So your answer is no solution. Or the symbol for no solution is a 0 with a slash through it. All right, let's try one more together, because again, a lot of these I'm going to have you just do on Desmos since I'm not going to be checking your work. So let's jump to the back. Let's look at number 14. I like number 14 because you do have to factor. So let me zoom in. Step 1, isolate your square root. Step 2, raise everything to the power of the index. The square root and the square cancel each other out. So you're left with what's underneath, 12 minus a. Well, now if we want to solve for a, we're not left with a linear equation. So we want to get everything to one side. So I'm going to add over my a, subtract over my 12 to get this equal to 0. I did that in all one step, but if you want to add over your a, then subtract over your 12 in 2 steps, that's fine. Now we have a quadratic in standard form where you have to factor. So your a times your c, your 1 times your negative 12 goes in the top. Your b, which is a positive 1, goes in the bottom. So two numbers that multiply to negative 12 and add to positive 1, that's going to be 4 and negative 3. We can jump to our factors, a plus 4 and a minus 3, since our a value is 1. You could have a difficult problem with a is greater than 1, and it'd be a long problem because then you'd have to group. So if I set both of these equal to 0, we'd get a equals positive 3 and a equals negative 4. You want to check them both back in the original. So if I plug them back in, I get 12 minus negative 4, or just 12 plus 4, which is square root of 16, which is 4, plus 7 times negative 4. So 4 plus negative 28. So that's negative 24. And then that would be 8 times negative 4, which is negative 32. Negative 24 does not equal negative 32. That one does not work. If I plug in my 3 for all of my a's, remember you have to plug it in for each of them and do the mental math, it would work. So in this case, your only solution is 3. Again, we'll talk about how to graph these so you don't have to do all of that mental math on the last step to check your solutions. Okay, so keep in mind the steps, which are written at the top of your notes. If you don't do this first step, your answers will be wrong. A lot of times you